Okay, so what I've got here is a quadratic. I know it's a quadratic because it has a highest power of x squared in it. And what I'm going to try and do is give you a sort of geometric representation, if you like, of how we factorise quadratics. Hopefully to unlock this for some of you, but otherwise it's just a bit of fun. I'm going to represent these with multi-link cubes, which I'm sure you've seen before in primary school. I dug out our set. I'm going to try and work with these today. So, I'm going to pick different values for x just for a minute. Obviously this isn't a proof, this isn't a justification, we're just looking at some examples that will hopefully help you see how some of these things work. So I'm going to take x equals 2 and x equals 3, just to sort of help us out a bit. So let's look at x equals 2 first. So x squared would be 2 times 2, which is a square like that. 5 x's would be 5 little stacks of 2. 4, 5, turns out I can count, that's good. And then 6 would be 6 ones. Now what I'm going to aim to do with these is turn them into a rectangle. That's it. So all I need to do is to turn all of these pieces into a rectangle. Okay, so I'm going to slide, let's put those two there, and put that one and that one and that one there, because that leaves me a gap of 6. Excellent, look at that. Great. Perfect. Okay, I'm going to do the same with x equals 3, and then we'll talk a little bit more about what we're doing here. So 3 squared is a 3 by 3. I can go there, that's 9. 5 x's, so 5 stacks of 3. Oh, there they are. And 6 units. Okay, same principle, going for a rectangle here. So let's go for 2 along there. Let's try the same pattern again. 1, 2, 3, perfect, that will work out. 1, 2, 3, 4, 5, 6. Great, okay, so we've made rectangles here, this is brilliant. This height here is a height of 5, and this is a width of 4. Now given that x was 2, I could also write this as x plus 2. 2 plus 2 is 4. And I could write this as x plus 3. 2 plus 3 is 5. Okay, let's see if this works on this one here. So here I've got a width of 6, no I don't, I can't count, a width of 5, and a height of 6, there we go. And now given that x was 3, I could rewrite this as x plus 2, and this as x plus 3. So in both cases, when I put together the multi-link cubes for this quadratic, my x squared, 1, 2, 3, 4, 5 lots of x and 6. I ended up with a rectangle that could be represented as x plus 2, x plus 3, which actually is that quadratic factorised.
So how about going the other way then? So how will I get to this kind of a process here with just algebra? So we can see that we're coming towards rectangles here, aren't we? And that's 2 measurements multiplied together. So I guess a sensible kind of idea might be to write what we've got as 2 brackets. Now, the first term in here, the first term of each of these brackets was our x plus something. And so I'm going to write both of those in. Now, algebraically, we can see that if we were to expand this out, which most people are pretty good at, x times x is x squared. Now, I need to deal with my 6 little units. Well, they ended up contributing to 3 along one side and 2 along the other. They're these bits here. I don't know if you can see them. There and there. And they multiply together to get 6, that little unit set on the end there. So 2 and 3 will multiply to this bit here. Now I was adding at every point, I didn't have to take anything away, and it just so happens that 2 lots of x, and I've just really helpfully drawn all over my work, so let's get back of all of that. 2 lots of x, which are these bits here, and then 3 lots of x will make up the rest of my expression. So I've actually done it there. There it is. There's my x plus 3 and my x plus 2. Now that was quite logic-y. I was just kind of sort of figuring out backwards and forwards and all sorts of things. What I'm going to try and do is give you a little bit more of a structure. But before I do that, let's look at what this looks like as a graph now. So I've changed my equations slightly just to mix it up and also to introduce some minuses. So what I'd like us to do is just to figure through that process again of how we created those multiple pairs. So we definitely ended up with an x by x. So we're going to deal with our x and our x. Now I've got minus 6 here. So I'm reckoning 3 and 2 might be a good bet for me. And I need to get to minus x. So actually I'm ending up with some subtraction in there. And it turns out that if you write minus 3 and a plus 2, well, I still get my minus 6. Minus 3 times 2 is minus 6. But I also get minus 3x plus 2x, which gives me minus x in the middle. And what's really key about these, like I said, I'm going to come back to the method in a minute, is that this, if I solve this equal to 0, this equation, which is basically asking where does this quadratic cross the line y equals 0, or the x-axis, so this line here, then this would give me that x is minus 2, which is this point here, and this one is going to give me that x is 3, which is this point over here. So in both cases, what I've done is I've actually been able to we could imagine what our rectangle, might look like. We've been able to factorize it here and also give a graphic, representation to this quadratic. Some other key features here: it's intercepting the y-axis at minus 6, which you can see in its equation here, and it's a positive quadratic. It's a sort of U shape as opposed to N shape, because the quadratic itself is positive. So let's go for a bit more of a formal structure with these. First thing I always do is identify my front sets, so x by x here. And then what I do is I write out the factor pairs of this last number. So 3 is a prime, it means I've only got 1 and 3. Now I'm going to work from right to left in my equation. So I've checked my factor pairs of 3. Now I'm going to have a look at this symbol here. If it is a plus, the two values in my bracket, the two signs need to be the same. They need to be plus and plus, or minus and minus. So now I know what I'm playing with. I can only use a combination of 1 and 3 in here, and it has to either both add or both subtract to, slide along again, plus 4. Well, plus 1 plus 3 would give me 4. So that's what I'm going to go for in my brackets. And that's it. I've factorised, which is quite nifty. Let's do the same thing with this second one. So here we go. I'm going to include my bracket pairs. There we go. And my x is at the front. There's only one x squared here, so I don't have to worry about any coefficients or numbers in front of those x's. But I'm going to start from my right hand side and I'm going to look at this. This is a 10, so I could have 1 and 10, or I could have 2 and 5. Those are the factor pairs of 10. Looking at this symbol, that is a minus, which means I need different signs on my brackets because I need to have 1 plus 1 minus to multiply to minus 10. So I need 1 plus and 1 minus in either order. And those two pieces of information needed to help me get to minus 3x. So I don't think I'm going to be using 1 and 10 because I can't add or subtract those from each other to get to 3 or minus 3. But I can here, plus 2 minus 5. Plus 2 minus 5. And we've done, we've factorised. Just getting a little bit more tricksy now. I've included a coefficient because I'm nice like that, I guess. So this time I'm going to have 2x and x in my brackets. I'm going to go through the same process though. So 3, I can only have 1 and 3. I've got a minus sign, which means I need different signs. I need 1 plus and 1 minus. Key before I start to get to try and add or subtract up to 5 is that I've also got a kind of times 2 power up. So one of these two numbers could be multiplied by 2 in order to help me reach 5. Okay, so if I multiply the 2 to the 1, if I add or subtract it from 3, I'm not going to get anywhere near 5. So I think this times 2 is going to apply to the 3. So 1 and what now becomes 6 can be made into 5 by doing minus 1 and add 3. Hopefully you're okay with that. If not, pause the video, rewind, see if you can follow it through again. So now the only key thing we've got to do is put these two values into the brackets in the right way. Now the 3 is the thing that needs multiplying by the 2. So it's got to go in the opposite bracket. Because don't forget, if you expand this out, this 2x will multiply to that 3. So this has got to be plus 3 and that's got to be minus 1. Now if I wanted to go ahead and sketch this quadratic, it would be helpful for me to know where it crosses my coordinate axes. So I know it's going to cross the y-axis at minus 3. To find my x-axis, I need to set y equal to 0. So 0 equals 2x minus 1 and x plus 3. I don't know what's going on with my computer. There we go. Excellent. Two things multiply together, equaling 0, means one of them has to be 0. There's literally no other options. So either 2x minus 1 is equal to 0, or x plus 3 is equal to 0. In which case here x is equal to, pull the 1 over, divide by 2, a half, and here x is equal to minus 3. So I've got solution points here at minus 3. This is a root and a half. There's another one. I've got a positive quadratic. So, oh no. Let's try that again, shall we? My quadratic is going to go something very badly like that. We'll imagine that's going through that point there at 3. And that's it. There is a geometric, an algebraic and a graphical representation of quadratics.